let's take a look at a couple parts of this question here. So here we've got a table of the world population, approximate world population in these years. And this data was obtained from this website, which is kind of a fun website to look at. It's got a lot of interesting information. So what we're going to do is we're going to find the percent increase in population from 1700 to 1800, then 1800 to 1900, 1900 to 2000, 2000 to 2020, and just take a look at how these populations are increasing as a percent. So remember, percent increase, let's recall the formula for percent increase. Do you remember it? It'd be good for you to try to remember it before I say it. So this is going to be basically the amount of change. So we're going to take the new minus the old, or the original, divided by the old. The new minus the old divided by the old. Okay, so if we want to find the percent change in increase in population from 1700 to 1800, then we're going to take the population in 1800, that's the new population, subtract the population in 1700, which is the old population. And then we're going to divide that by the old population, which is the population in 1700, or the original. Probably use original in some instead of old, but they mean the same thing. Okay, so this is the first time that we're really talking about subtracting with these kind of numbers. So we want to talk about that a little bit here. So to find the population of 1800 minus the population of 1700, we need to subtract these two numbers here. So let's write them out in scientific notation, or as a power of 10. So 1 billion is going to be 1 times 10 to the, a billion is 10 to the 9th, right? And then 610 million, we could write it as 610 times 10 to the 6th, or we could write it in other forms as well by moving that decimal around. Now, we don't have any rules for subtracting these things, okay? If we're going to take 1 times 10 to the 9th, subtract 610 times 10 to the 6th, we're not doing anything with the exponents here, okay? Remember, you subtract the exponents or add them when you're multiplying and dividing. But one thing we could do, if we want to take 1 times 10 to the 9th minus 610 times 10 to the 6th, is try to write these as the same, these powers of 10 as the same thing. So I'm going to change 1 times 10 to the 9th into something times 10 to the 6th. Can you think about what that would be? Can you think about what that would be? I'd have to have 3 zeros of change, right? I'm moving from 9 to 6. So we're going to have 1,000 times 10 to the 6th. Let's think about that. 1,000 million, 10 to the 6 is a million. 1,000 million is the same as a billion. So now if I write these as the same power of 10, so I have 1,000 million, take away 610 million. This is almost acting like terms. Okay, like if you thought of these as an x, you'd have 1000x minus 610x. So we can just do 1000 take away 610, which is 390 million. 1000 million take away 610 million is 390 million. Now the other way you could do it, of course, is to write these numbers out with all the zeros and do a subtraction. But this is the way that we would add and subtract with scientific notation. We're not going to see a lot of this, but I thought it would be good to look at least one example. So the change in population is 390 million people out of an original in 1700, 610 million people. Okay, so let's do this division. Let's punch into our calculator the 390 divided by 610. I don't like that green on green. Let's do a different color. You punch that in. Let's do hot pink on green. How's that look? Oh, that's a little startling. Okay, 390 divided by 610. We get 0.634, so let's round that to 639. Let's round it to 0.64 because we're doing a percent here, right? So this 10 to the 6 divided by 10 to the 6, what's that? These are the same, right? 10 to the 6 divided by 10 to the 6 is 1. If we use our rule about subtracting the exponents, we would get 10 to the 0. 6 divided by 6, or 6 minus 6, right, is 0. 10 to the 0 is 1. Anything to the 0 power is 1. But we can just see those are going to cancel. So 0.64, I'm writing this as a percent. Percent increase, 0.64 is 64%. So we have a 64% increase in the population from 1700 to 1800. All right, why don't you try part B? Pause the video, try part B, and restart it when you are done. Okay, how's your setup look? Population of 1900 minus the population of 1800 divided by the population of 1800. Make sure you're dividing by 1800, the old or the original population, before it increased. So these are given to us in billions. Do not write all the zeros out. You're subtracting a billion, something in billions minus something in billions. So this is set up for us very nicely. All we have to do is take 1.6, subtract 1, and our answer will be in billions. All right, the 10.9s don't drop out and go to 0. You're taking like 1.6 cows minus 1, well, 1.6 cows. That's not a very nice thing to think about. 1.6 billions take away 1 billion is going to leave you 0.6 billions. 0.6 billions divided by 1 billion. Okay, let's punch in 0.6 divided by 1. You've probably already done that. And we got 0.6. Oh, duh. I punched that in. That's funny. Time for more coffee. It's early in the morning right now. 1.6 divided by 1. Anything divided by 1 is itself, right? Okay. And then these 10.9s, this 10 to the 9th divided by 10 to the 9th, that's just 1. So we get 0.6, which as a percent then would be 60%. Okay, kind of interesting. So the world population increased 64% from 1700 to 1800. And then from 1800 to 1900, another 60%. So these are pretty much on track, kind of similar. Let's go ahead and tackle part C and see what happens between 1900 and 2000. So go ahead and tackle that and unpause the video when you're done. Okay, how did you do? So we're going to take the population of 2000 minus the population of 1900. So that's 6.1 billion minus 1.6 billion, which is 4.9 billion. So we had an increase of 4.9 billion people in the world population between 1900 and 2000. And then we're going to divide that by the population of 1900, which is 1.6 billion. So we're going to punch into our calculators 4.9 divided by 1.6, and that's going to give us 3.0625. The 10 to the 9th divided by 10 to the 9th is 1. So those are going to basically go away, multiplied by 1. Now, we're supposed to write our answer as a percent. This is not in a percent form right now. This is in a decimal form. So to change it to a percent form, we need to move the decimal 2 places to the right. And this is going to be 306. We could round to the nearest percent. Let's just do that. 306% increase. Now you should expect that from the numbers that we see. If we went up almost 5 billion out of an original 1.6 billion, that's more than double. So we would expect more than 100% increase. A doubling is 100% increase. So you always want to check and make sure your answer makes sense. I get a little nervous that some students might think the answer is a 3% increase because this came out to be 3 point whatever. and just forget to move their decimal. But you always need to think about the reasonableness of your answer. If these up here are 64, 60, 64 and 60% increases, this is a much bigger increase. It's not a 3% increase. And that'll help flag some little mistakes maybe, is always thinking about, does this answer make sense? All right, well, why don't you go ahead and finish part D on your own and find the percent increase so far in the next century from 2000 to 2020. Kind of makes you wonder how this percent increase is going to go from 2000 to 2100. I will not be around to see what happens, but this is pretty significant population increase in these decades from 64 to 60 to 306. What's going to happen? What's going to happen here? I do not know. We can kind of see, we could see a trend, at least deal with the population we have so far and see what's happening.